Hello, can everyone hear me? Yes? We're good? Are we live?
I guess we can, I don't know, wait for 2 more minutes or so in case somebody.
Okay.
But we're probably the only workshop that has the 45-minute schedule, do we? So there's not.
Yeah, I believe so. This is also a very generous schedule. This is more time than I had to defend a PhD thesis.
Yeah, okay. Yes, I wouldn't want to start earlier. The question is we have to wait, but I've seen people come in that went for this particular talk, so looks like it was possible. So far, yes. Well, I guess I can start. The intro, welcome to the second half of the second session. Sounds like a dramatic progression. Our next speaker is Jeffrey Young. He is in Seattle, but unfortunately, health-wise, decided to stay away from us. But he still wants to spread the knowledge, even not the germs that he may have or may not have. And good to see that you're up and about and not you don't look too. I hope you're doing fine. Thanks for still giving the talk. Yeah, with that, I think you can take it away.
Okay, let me start my timer. There we go. Hello, everyone. So my name is Jeffrey Young. Yeah, I'm here on behalf of my co-authors and IOG, a company I work for, to present our paper, Stretching the Glasgow Haskell Compiler, Nourishing GHC with Domain-Driven Design. So I have the plague, which is I went to one day of HIW, and then I got COVID, and so that's why I'm not in person, sadly. So you'll probably hear me cough. I'm sorry if my voice is a little deep sometimes, but we'll just have to make do. If you have any questions, I have my email at the last slide. You can reach out to me or read our paper. I'd appreciate it. Okay, I want to begin the talk with the takeaway message. And I have 2 points. So if these are the only 2 things you remember, I'd like you to walk away with these 2 points. That is, architecture is a choice. So I really think this is a cultural value. And what I mean by this is that Haskell will not save us, but Haskell allows us to save us ourselves. And so what I'm interested in is in understanding how we can have the properties of functional languages that we enjoy at a system scale. And more importantly, how do we lose these properties at the system scale level? And then my second takeaway point is that which is difficult to change is difficult to learn from. So if you cannot change your system or your code, then how will you experiment? And if you cannot experiment, then how do you improve, right? How do you iterate? And what I have in mind here is something like a knowledge hazard, but really it's a pedagogical hazard, because if you cannot experiment, then the future systems you were capable of building has now shrunk because you can't learn from your current position. So I'll have more on this later. Okay, so moving into our project, what we want to do is we want to contribute to what I learned earlier this morning from Michael's talk, is the burgeoning functional architecture discourse. And we want to use the Glasgow Haskell Compiler as an example. So we want to describe patterns in GHC where, from our experience, we've lost functional properties, describe how we've lost those properties. Then I want to abstract these patterns from in our experience refactoring GHC with domain-driven design in response to these patterns. So I'm going to begin with a list of caveats because this is a workshop and this is an experience report. First, I do not mean to criticize GHC. It's as old as I am. It is a venerable code base, and it has survived some truly harrowing refactoring, which I think is a testament to Haskell as a from GHC. So I want to treat it as a data point in a continuum of possible systems. I want to think of it as a finch on Simon Peyton Jones' Galapagos Island, and I want to understand how this finch is evolved into its particular niche, something like that.
Jeffrey, interruption. Can you hear me? We occasionally get short drops. They're not horrible. but might be better without. Maybe turn off your video so that your upstream is less,
Okay.
maybe a little bit saved. And I mean, we like
Is
to
this
see you, but
better?
let's try this for a while. Yeah, thanks.
Okay. Interrupt me again if it happens. Yep. Okay. Caveats. My second caveat is that our contributions are not really technical. What I really think they are is they sit at the interface between technology and psychology. And what I mean by that is they're more about how a human interacts with the code base and how the code base guides their hand to propagate, I guess, anti-patterns. So to sum this up, I want to say bugs are written by people. They don't just occur. And then my next caveat is our recommendations are really simple, but that doesn't mean that the problems aren't real. So I think they exist. I hope if you're in this room, you think these problems exist. If you don't think that, I hope to convince you. And then lastly, please interrupt me. This is going to be harder over the internet, but I guess we'll make do. But I prefer interaction over just a lecture or exegesis. Okay, I'm going to get into definitions, and then I'll pause to make sure my audio is good. So when I talk about a system, I mean the entirety of a piece of software. For example, for GHC, the system would be its entire implementation, its API, all of its documentation and dependencies. When I say a subsystem, and I'll use subsystem and component interchangeably, I mean a particular piece of the system that is critical for operation. So for example, the core to STG pass in GHC or the parser is a component of GHC, the system. When I say domain, I want you to put on a hat like Connell Elliott, and I want you to think of denotational semantics. So what I mean by domain is I mean the abstract representation that the system realizes. For example, the domain of data.map is information. It's an abstract mathematical specification that our implementation is seeking to realize, which leads me to implementation. This is the thing I work on day in, day out. This is the thing I commit code on, the thing that CI runs. This is your concrete project that realizes the system and the domain. Was that okay? Audio-wise, still good? I'll assume yes. Okay.
Sorry, yes, that is yes.
Okay, great. Okay, now on to the anti-modular anti-patterns. Our first anti-pattern is called shotgun parsing. Here's some code from GHC. It loads interface files, which is how you get cross-module inlining and ad hoc polymorphism and specialization, a bunch of nice features. What shotgun parsing is it's a mixing of processing code with input validation code. Here, the processing code is everything in the special handling do block that it's pointing to at the orange arrow. And the input validation code is this predicate is whole module that checks that the input module is actually either hold and has to get special treatment or not hold and gets default treatment. This term is defined in Alexis King's parse don't validate post. If you Google for it, there's not much that comes up. So I just wanted to show where the genesis of the term came from. Shout out to Alexis if she's in the audience. Okay, so I want to reinforce before talking about why this is an anti-pattern that this was a purposeful design. So it comes from Backpack, where with the advent of Backpack, the domain of modules changed. So you had modules as they always were in Haskell 2010 and Haskell 98. And then you also had modules that were parameterized by holes, which could be filled by other modules. And so this note, which is still present in GHC, claims that if we change the data type, which represents a module, then that would make the existing module name and module unit partial, and it would be too hard and require lots of modification. So it was deemed too difficult, and that's why we have a special whole unit value, which this whole module predicate checks, which leads us to the special treatment. Now, I don't think this note is up to date because module name is just text and module unit already has a constructor for whole module. So perhaps it's time to change, but I'll get more on documentation in a bit. Okay, so back to shotgun parsing. Why is this a problem? Well, the first problem with shotgun parsing that's dear to me is it's a performance problem. Shotgun parsing relies on runtime checks, and each of these checks are branches and they can be redundant. What I mean by redundancy is here's some pseudocode, but load interface is called on mod, and load interface will check if mod is whole module, right? But it'll complete it because that information is never propagated to foo. Oh, my internet connection is unstable. And there we go, I'm back. Okay, because that information is never propagated to foo, that means foo has to check if it's a whole module. Okay, so coupling. This is the second problem with shotgun parsing. Subsystems that handle module must always check for is whole module, and that's why this predicate proliferates, and that's how we end up coupling. So here's an instance of is whole module in Haddock. I'm not familiar enough with Haddock to know why this has to be called. And here's other subsystems will also build on top of this design. So here's the same, a similar predicate in the name module for GHC.types called is whole name, and then is whole name is used in the core component in type constructor Skolem. And if you're curious as to how many instances of these predicates there are, I counted around 56 between just is whole module and is whole name. I didn't check Tycom Skolem or anything that built on Tycom Skolem. So I think that's a rather high number. Okay, so why is this a problem? Continued. Well, I conjecture that shotgun parsing is a major source of bugs. So if we remove all of our special handling code, what happens? The answer is absolutely nothing. Our type check we don't get no type checking error. The type signature doesn't even change. All that happens is a bug is silently introduced. This might not be a problem if your system is small or relatively young, but if your system is 30 years old, trying to get to 40 years old, and if you have a rotating crew of developers that are constantly onboarding and leaving for other projects, then I would say code changes like this are more within the realm of possibility. And so making so that a change like this forces a type change or a type check error, I think is good. Okay, so why is this a problem? Continued. We hypothesized that shotgun parsing leads to bug-driven development. Here's a function in STG to CMM.heap that has lots of type checking code where it's
You just dropped out after where is.
This module, I just grabbed it because it had 7 guards and looked like it was doing manual. More, we continue to avoid the type system because the status quo in the software system is not to use the type system, it's to add guards with is predicates, right? So this is the kind of, the code is nudging developers into certain implementations, which in this case, I think is bad. It's not avoiding the type system. So the lesson, shotgun parsing results from avoiding typing the domain. We should use types to create a robust implementation. I think that shotgun parsing is performing a manual kind of type checking, like JavaScript's type of. We already have a system in GHC and Haskell that tells us if the inputs are of the right type as defined by the type signature. That's called the type system. And using the type system is declarative. We should use the type system. The domain always has types. So those types are either going to aid you in the implementation or they will manifest as ad hoc runtime checks for special cases. And the reason your domain always has types is because you will always have to differentiate between one thing in the domain and another thing that has a different behavior in that domain. So don't run away from the types. Let them guide you. And to tie this up, I think this is a way we lose modularity at the system level because of the coupling with these is predicates that have to proliferate throughout the system. Okay, so my second anti-pattern is layering violations. Consider this code. This code makes a literal integer. This code does not exist in GHC anymore. We've fixed it. But this code is exemplary of a layering violation. The layering violation is a breach in the abstraction barrier between two or more subsystems. Here, the breach is the input dyne flags, and the abstraction barrier is the entire function make literal int. So what's the problem with this? Well, the first problem is that dyne flags is part of the driver. It holds the command line information that GHC is called with.
Jeffrey, you're breaking up again at the end of.
And must, yes.
We heard you until the make-lit int is part of the domain. Maybe repeat the last bullet point.
Okay. So the violation is because dyne flags is part of the driver and make-lit int is part of the domain. So this might not be clear yet, but I have slides about how this is an exact violation coming up. That was the last point. And then the point I'm on is callers of make literal int must have dyne flags in order to create a literal int, to call make lit int. That means that the caller must import or to import ghc.driver.session. Now the caller's component is coupled to ghc.driver.session. And then this means that dyne flag spreads and becomes part of the de facto internal API. So there's a code concept of code gravity that talks about how these massive records end up attracting more and more code, which I have in related works if you're interested. So the problem here is that the layering violation spreads, it's infectious, and it couples components just because in order to make a literal int, I need a dyne flags. Hopefully that was clear. And then to tie this up, this is how we lose modularity and composition at a system level. Dyne flags is essentially like a global mutable variable that's being passed around these components at the system level. So the lesson, one, layering violations have two effects. One is coupling, and the second one is infection. They create paths of least resistance that spread additional layering violations. And I go in more detail in the paper. Okay, now on to GHC with domain-driven design. So I won't spend too much time on this slide. Michael already introduced domain-driven design earlier today, which I thought was very good. But essentially, this is a approach to software development. It comes from OOP. It's 20 years old, and it's about having a domain model that you're programming towards. What we want from domain-driven design, really this philosophy that guides our work called supple design. The idea is to try to make the system as easy to change, easy to experiment on as possible. And we think Haskell's quite good at this. So for example, how much work would it be to swap the parser? How much work is it to add a new backend or target a new platform? I want to reinforce that this is not just an aesthetic judgment. So non-supple designs are hard to change. Because they're hard to change, they're hard to experiment with. Because they're hard to experiment with, they are hard to learn from. This is my second takeaway.
You just dropped out after stating that this is your second
principle here.
Takeaway.
Still good?
You're back there, but please start again from where you said that this is your second takeaway. I think
Okay, yes. So the second takeaway is because they are hard, is the pedagogical hazard. So non-supple designs are hard to change. When they're hard to change, they're hard to learn from because you have a harder time experimenting. This also comes from domain-driven design. I'm going to take a bit of a detour to talk about graphic design. In graphic design, when a graphic designer makes a logo for a brand such as Apple, they construct a document called a brand book. The brand book is the single source of truth for how to use that logo and in what places to use that logo. What does that mean in practice? Well, that means what kind of colors you should place that logo on top of, what kind of colors is that logo capable of displaying. So the Apple logo should either be in black on white or white on black. It should not be in grayscale. So you see here's how to use it, here's how not to use it. it gives you guidance on how to avoid signature mistakes. So do not change the font or alter the spacing, for example. Do not repeat it ad nauseum. If you're going to put the logo on a storefront, how high should it be? How much distance should it be to the edge of the store? And if you're going to put it in a document, how many pixels should it have as a buffer around the logo, right? And these are all described in the brand book. So this is guidance. What I really think this is it's a tool for many individual agents to act consistently. And so I'm asking, why don't we do this for our systems as well? We do this for logos, and I think we should do this for our systems and components as well. And excuse me, this is not a hypothetical problem. So yesterday I was working on some performance regressions in GHC, which is a pastime of mine. And I found this function called find wired in units. In this function is a local function that's described by this this comment right above it. And the comment just says, find which package corresponds to each wired in package, delete any other packages with the same name, and so on and so forth. But package is not represented in the types at all. And indeed, you're right. That comment's from Simon Marlowe. Nope, I lost internet again. Unfortunately,
we heard you until saying that package is not represented in types at all.
Right. Yeah, it's only represented in this local variable name. You might say that this comment is out of date, and you would be correct. It's out of date the last time it was written.
We heard you until the last time it was written.
It was written in 2006 by Simon Marlowe. So you can blame him. Is that good?
It's good enough. We heard you. Simon isn't here, so we can't blame it directly, but we'll do it later.
Okay. So moving on, I want to say that this is also a current problem. So in the 2023 Zurich, Duncan Coutts had a language of packages. And so that's the language before backpack. And so even at the to Cobble or to GHC. And so even in a workshop of experts, we had this problem of not having a ubiquitous language. Hopefully that was clear. So just to be clear, Cobble packages are made up of components. GHC is only interested in library components. These are called units once compiled, and a package is a set of units. And so this is described in a note in GHC called about units, which should really be in the user's guide.
We heard you until in the user's guide.
Of truth. And I'm going to skip the rest of this slide just because I will need the time because of internet problems. So our recommendation is do this, write the guidance, make the brand book, make your naming precise, meaningful to the domain, consistent, documented, and checked by the type system. And I also want to point out that this is happening in other areas of computer science. So Tim Gibru has an initiative, Data Sheets for Data Sets, which is providing guidance on what kind of data sets are useful for particular kinds of large language models, just as you would get a data sheet for electrical components like a resistor or a capacitor. And in fact, we've had performance regressions in GHC where someone has used the fast string component incorrectly, or I guess not incorrectly, because the module of fast strings did not give guidance to that person on how to use it. So they used it inefficiently, and then we had a performance regression. Okay, my second design principle is layering. So how shall we structure large-scale systems in a functional language? We argue that for GHC at least, we should do this in 4 layers. So this is a layer design. The 4 layers are presentation, application, domain, and infrastructure. And I'll end user, it's any consumer of GHC lib. These are things like GHCI, HLS, event log, program coverage tool HPC. Application defines the jobs that the system performs and coordinates lower layers to realize these jobs. This is GHC's driver, its build plan, or how the driver makes the build plan, doing recompilation avoidance, that sort of thing. And then domain is everything that the stuff papers are written about. So you might have seen this rather dated compilation pipeline now. In my notation, that looks like this. So it's the parser, renamer, type checker, all this stuff, core, all the backends. And then infrastructure, the idea behind the infrastructure layer is that the upper layers all need these generic capabilities. They need these services. And this layer is the bottom. It provides these services. So that's logging, file system errors, loading and
we heard you until file system errors.
Oh, that's okay. Yeah. That was the end of my slide. So this is a layer cake. Oh, there's my internet goes unstable. My apologies to the audience. Am I back?
Yes, we can hear you right now.
Great. Okay. So within a layer, components can depend on each.
And no, we don't hear anymore.
Application can depend on domain, which can depend on infrastructure, and so on and so forth. Okay. And then communication should arise through the hierarchy indirectly. To the driver will say, I need to parse the module, and then I need to take that result and turn it into core, and then take that result and turn it into SCG. In order to do those things, it'll call functions from domain and so on and so forth. That's what I mean by indirectly. And then the module structure should explicitly follow the architecture. And I have an example of this in the next slide. I want to point out the lack of a module called
You broke up
time reasons.
Saying, notice the lack of.
Okay. Yeah. I'm going to skip that point just so I have more time to get to other things. Does this layering realize a supple design? It enables componentization and component-wise configuration. It provides more opportunities to parse, don't validate, because it gives us better abstraction barriers. And it represents the domain in the implementation more succinctly. What I want there is I want to also use the module hierarchy as a way to think about my domain, right? I want it to be a tool of thought. So if I have a dependency that I can't disentangle, I might think, oh, that's very interesting. I've learned something about my domain. And then I want to argue that layering violations become obvious. Here's what I mean by layering violations become obvious. So this is real code in GHC as of 2 days ago. This is the CMM to LLVM module or component. Can you spot the layering violation? I'll give you a few moments.
Somebody audience said session.
Someone in the audience knows. If it was Josh or Leita, it doesn't count. They've already seen the talk. So if I explicitly show the layering in my module hierarchy, is it more clear to the people who didn't know? It should be, because you have ghc.present driver session being imported in ghc.domain.cmm to LLVM. And this is what I mean when I say layering violations become obvious, right? Because just from the imports, you can tell. So good to whoever figured it out. So our recommendation is to use a layered architecture and explicitly represent the layers in the module hierarchy. It would be interesting to see what this would look like with a hexagonal architecture. I have not thought about this, but I would love to talk to someone who's more familiar with hexagonal architectures. Although I think the layered architecture makes a lot of sense for a compiler. Okay, so
Michael
my
is
next
nodding
design.
vehemently. Yeah, sorry, carry on.
My next design principle is componentization. So here's some code that performs linking in GHC. It inputs DINE flags. And just from the type signature, you cannot tell what link uses from dynamic flags, right? Componentization is unbundling these components from massive records like DINE flags. So now you can tell exactly what link uses and its API is. I can update or add things to DINE flags in the previous version without changing every call site, right? With this version, now I have to change every call site. And I would say, but that's exactly the point, that you have to change every call site because that would be a type error. And that's good. That's the type system telling you, hey, this has changed, right? And drawing your attention. And then secondly, I would argue with these large records, like 191 fields in DINE flags, the effort to reach an exotic operating condition is exceedingly small. You only have to change a few before you're suddenly running a GHC that no one has ever run before and that we cannot cover in our test suite. You're way outside of operating conditions. So consider the case where link requires a different kind of component, say special logger. With the new API, this is checked in the type system, and we can provide the special logger without changing tempfs or unit environment at all, which is good. That means our change is more local. Instead, if we supply to DINE flags that is silently changed, we have no idea that it is silently changed in the type system. And if link propagates that DINE flags forward, then it also, whatever receiver of that DINE flags is checking it, won't know that it will have like a special logger in it, for example. So I'm arguing that this sort of behavior, just having these large records, is a way we lose purity at the system level, because it's essentially a global mutable variable that's being changed by each component as it's being propagated through the system. So our recommendation is avoid passing records of functions. Instead, componentize and explicitly pass each component, even if that's painful, which in general, I don't think it is. And we've had a lot of success with this in GHC. All right, my last design principle is component-wise configuration. This is the idea that each component in your system
We heard you until saying the idea, so maybe repeat the idea.
extreme. Oh, yeah, I lost you again.
Can you start again from the idea is?
The idea is to treat components as they have their own bounded context, and they should be viewed as if they are external systems in and of themselves. So I'd like to talk to a DDD, domain-driven design expert too, because this might be a bit. Consider the CMM component. The CMM component requires information that DINE flags holds, but it cannot use it because that would be a layering violation. So instead, we do two things in GHC now. First, we define a configuration record that holds all of the information the CMM subsystem needs, right? And this is defined in the CMM subsystem. And then secondly, we define a handshake function. Okay, maybe not.
We heard you until define a handshake function.
Okay, that's pretty good though. So you define a handshake function in an upper layer and pass it down to the subsystem that requires it, in this case, the CMM subsystem. What this looks like in GHC, this is real code, is here we compute the CMM config using dyn flags. And then we pass that to the CMM pipeline, which is the top level function for the CMM component. And notice that this happens in ghc.driver.main. So this should beg a question if you've been following along. Why not move the init CMM config function into the CMM subsystem? And instead of being dramatic, I'm just going to give you the answer because I'm running out of time. The reason is that this would
You broke up just before saying the reason. We're all excited to hear the reasons.
Yeah. The reason is that init CMM config requires dyn. Can you hear me?
Now again.
Okay. The reason was init CMM config needs dyn flags. That's a hint that that function has to be in the application layer. So our recommendation is aggressively isolate components, treat them like separate systems, and isolate by defining system-specific configurations and handshake functions. And in practice, this has allowed us to write tests which were previously impossible because now we just have to supply CMM config, which only has 9 fields of booleans instead of 191 fields of dyn flags, where we're just making up information just to pass the record. Again, we want to test normal operating a normal operating range, not these exotic ranges, which could happen from Yeah. Okay, good. You can still hear me. Great. I'm going to conclude. Thank you for bearing with me. I didn't have room. Okay, well, I will just list my references. So the Co-Recursive podcast has an interview with Debashish Ghosh on domain-driven design means functional programming. This is in Scala. Alexander Granin has a Manning book on functional design and architecture that explicitly applies domain-driven design to Haskell. Carlo Pesio is a series in code. Am I back? I think so. Okay. Yeah. Where the idea of mass and gravity in code. This explains things of how dyn flags, its genesis. I think it's a quite useful concept. I didn't have time to go over it because of our connection issues. And then the Tech Lead Journal podcast has also got an interview with Scott W. I don't know how to pronounce his last name, on domain modeling made functional, which was a book. No? Okay, there I am. All right, now I'm back. No, it's very bad. Okay.
So we move.
The last reference.
Shall we just move to the question section? Or yeah, your
Sure.
final. I mean, of course, final slide.
This is the final slide. Sure. Yes. Here, I will put everything down. Okay. So please. Okay, we'll call that done. Unfortunately, we had significant connection issues. So if you're interested in this stuff, the paper is Stretching the Glasgow Haskell Compiler. This work was funded by IOG. You can reach me at Duganu on IRC or at my email, jeffrey.young@iohk.io. And thank you for your time. I apologize for the connection problems.
Yeah, thanks a lot. I think this was a very interesting presentation style because it required the audience to be alert to fill in the blanks when you were like dropping out for half a sentence or so, and it was actually it kept people on their toes. I still think we got most of the things you wanted to say. And I hope there are, there are already questions. So let's start ahead with it. We have like 6 more minutes for questions, so some time.
All right. Hi, Will Creighton from Brown. Can you hear me?
Yes, I can.
Great. So one thing I was wondering is how you feel about how this proposed kind of design for a compiler relates to cross-cutting concerns. I don't know about GHC, but one issue in, for instance, the Rust compiler is spans, source spans. These things are pervasive. They exist everywhere. They have to be interned in order to be efficient. And so there's some global context that maintains span interning. And one way in which that's really annoying is every single time you want to test any component of the compiler, you have to make sure to call these context functions that are like, oh, initialize the span session globals, whatever, or else you get panics of saying, I can't instantiate this object. Even if you don't care about spans, you still have to care about this aspect. And so I'm curious if there are those kinds of cross-cutting concerns appear in the in GHC and how that relates to the architecture you're proposing.
Okay. So I didn't get everything, especially the definition of spans. As for cross-cutting concerns, I think that cross-cutting concerns are an extremely hard problem, but they're also ideally exceptions. And so I think that they should be treated as exceptions. They should not be the norm. Whether they exist in GHC or not, I'm actually not too sure, just because I work very deep in the pipeline, and I would argue that most of the cross-cutting concerns are probably in the type checker, but I'm sure someone in the room also can speak to this. I don't think I quite answered your question, but hopefully that was at least a gesture in the direction.
Yeah, that helps. Thanks.
Hello, this is Facundo Dominguez from Twig. So I wanted, so these layers that you have proposed, these layers that you have proposed make sense. The domain layer in particular is still very large. So would you still hope that it can be organized with the same principles, and or do you anticipate that more considerations will be necessary to make it to break it down into components?
Yes. Hello, Facundo. I recognize your voice. I do think the domain layer is very large, but I also think that treating it as a pipeline makes it very easy to deal with. It also makes it easier for the driver to organize the specific components. Now, whether it should be organized in a further manner or maybe like recursively in another layered type architecture, I am not completely. There we go. I think I'm back. I'm not sure if domain-driven design actually has an answer for this, but I'm also unsure if having large layers is a problem. My actual answer to your question is if we tried to treat the domain layer as another layered architecture, we'd end up, I'm sorry for the connection issues. We would end up, I think, with more infrastructure that would be spun out. And then I think we would end up having dependencies that would move to other layers, if that makes sense. So maybe a further decomposition is possible. For GHC, I think the domain layer is pretty well defined and controlled now after the module hierarchy in 9.0. Maybe other GHC developers feel differently. We'll have to ask them. I'm not sure. Hopefully that answered your question.
Hi, Jeff. This is Richard Eisenberg at Jane Street. So you've outlined a couple of sort of ideals in your talk. I really like the different sort of ways to break it down. So there's suppleness, there's performance, which was not a key aspect of the talk, but something that you brought up on the side. And then the I guess sort of I want to call it correctness, in that your first example about shotgun parsing is to sort of have finer grained types. I feel like these are all really in tension with each other, and we can't get all of them. I'm not even sure we can get two of them. And I mean, when you have really fine grained types, for example, it makes code harder to refactor. I mean, it depends on the nature of the refactor, right? Sometimes it makes it really easy. Sometimes it makes it harder. When you have to break apart dyn flags into all of these components, and then you're copying out aspects of the dyn flags, that takes runtime cost to do that. I'm just sort of curious what your thoughts on sort of how to balance these different priorities, because or maybe you don't see them in tension. Maybe you sort of disagree with my premise, but I'd be curious to hear about that.
So I accept that there is a bit of tension here, where you have to pattern match on a big record like dyn flags to pull out different fields to make other configuration records, things like that. I think the tension makes more sense if you are trying to hold them as equal goals. And I would argue that I did cite some performance things with shotgun parsing here, but I do not hold performance at the system level as an equal goal. And I think it's fine to recognize where the hot path is and don't be modular there in order to remove certain overheads. So in that sense, I'm willing to bite the bullet that you have provided, Richard. Thank you for your question. I do want to point out, though, that what I'm interested in here is trying to have code that is in a way more self-documenting. And so having a really finer grained types is a way of doing that. And I think that having more type errors is actually a good thing, because I think that leads to more maintainability as long as the type errors are actionable. Whereas with having large dyn flags that are passed around, you won't know that's an error until the test suite tells you, and then it's really going to be some time before you understand it, because now you have to either rebuild the compiler or use some sort of profiling to understand what's happening. And so I would prefer the maintainability of type errors before having this large mutable record be passed around like dyn flags. Now, if performance is more of a goal, there is, and this will be complete heresy to a lot of people in the room, the venerable implicit parameters language extension, which would completely throw maintainability out the window, but then you would avoid pattern matching on large records to pull out fields, and you will get more performance. So maybe there's some judicious use of that. I would argue we should not have any use of that in GHC, even if it means our compilation time is a few minutes longer. We can just wait a few more years and the M4 Mac will come out, and then we'll compile in 11 minutes instead of 14 or something. Yeah, I hope that answered your question.
Okay, we're running close to lunchtime, so one last comment from Michael.
Yeah, so I'll try to make it more a comment than a question. So first of all, I think you're right. It would be interesting to think about hexagonal architecture and moving the lower level in your layer hierarchy down, moving that outside. I think also that domain-driven design has answers for structuring the inside of your domain at GHC, but they're not the right answers, because you would think in terms of aggregates and entities and value objects, and I think functional programming has better answers to that. One other way to frame your validation thing was in terms of, I think Ron Minsky coined the phrase, make illegal states unrepresentable, right? This is not necessarily a types thing. This can also be done without types by just having the constructor validate the arguments. Unbelievably, this is something that is completely local to the functional community, even though it doesn't really have anything to do with functional programming. So if you talk to the object-oriented people, what they do is they create all their objects and then they validate with complicated frameworks. And this is like a small thing. So what you said was all spot on. This is a small thing, but this could be a contribution that we make to the larger architecture community, since validation plays an important role in domain-driven design, but they don't know how to do it right? You would think this is completely applicable to object-oriented programming as much as it is about functional programming. So if we were just to communicate better, we would own this, and we're not. Yeah. So
yes,
thanks. So I agree with everything else you said. Obviously, Jeffrey. Thanks.
All right, let's thank Jeffrey again and get well.
Unfortunately, I also wanted to talk to you, but unfortunately that has to happen virtually. One of the ways I view this work is guidelines for negotiating a large code base into a structure that is more easily suitable for parsing and not validating. I believe that was what you had commented on, but it cut out halfway through. So anyway, yes, I'd like to talk more, Michael, and I do think.
So now we can all guess what he thinks. Yeah, I think we should. Let's wrap up here. We start again at 2 with software architecture based on coarse-grained self-adjusting computations by Stefan. And until then, have a good lunch.
Thank you.
Get better soon.
Yeah, I'll try.